Hello everyone, this is Praveen. Welcome to Praveen Tutorials. In the last live session, I discussed with you about acids, bases, and salts. In that, I discussed with you about pH scale and also importance of pH in our everyday life. So here, what is pH? Simply, we define that pH is negative logarithm of H plus ions concentration is given as pH. pH also known as universal indicator. That universal indicator helps us to find out the acid, base, and neutral nature, as well as strength of the substance. Then that pH paper also useful in our day-to-day life to decide the nature as well as strength. So here pH gives you different colors and consists 0 to 14 values here. Each value will be with different colors. So based on the color, you are able to identify the nature and the strength. Then here, importance of pH in our day-to-day life. We discussed about importance in a daily life. In an aquatic life, that means plants and animals are they sensitive acidic rain. If that rain water pH value lower than 5.6, then it is said to be or considered to be acidic rain. Then in our mouth, tooth decay. If the pH of mouth falls below 5.5, that acid in our mouth affect directly teeth. So called as tooth decay, cavities. Next one is importance of that pH in our digestive system. If the digestive system, gastric juices are released here. So here neutralization with antacids, acidity problem. Then pH of soil, healthy growth of plant. If the pH range is between 5.5 to 7.5, plants grow healthy. It is changed, then directly it affects the productivity and also plants. Right. The next self-defense by animals. So these are the importances we discussed in our daily life. Then the next topic is about salts. Here, what are salts? Before going that, already we learned how the salts are produced in the activity number 5 by the neutralization reaction. What is neutralization reaction here? Simply the reaction carried out between acid and the base is called as salt. Here, it is not compulsory to produce the salt always with the neutral nature. It may be with acidic nature or maybe with the basic nature or neutral. So depends on the strength of the acid base reactants. Strength of the acid greater than or more than strength of the base. That salt may be with the acidic nature. If the strength of the base is more than the strength of the acid, strong base, weak acid, then the salt nature may be weak. That means here strength greater, that is maybe with the basic nature salt. If both are strong, maybe neutralizes, right? So here simply what we are going to say about the salts here. Simply salts are said to be here ionic compounds that which are produced by neutralization reaction. Simply we can say that the reaction is here acid and the base reaction that produces here salt and water. So ionic compounds. Salts are simply ionic compounds. Then here we are able to classify these salts as families. How we can classify them? Simple. Here, suppose if you observe different salts, in them or in the composition of the salt, if you find any atom commonly or maybe the group of atoms or group of ions, single ion or group of ions. Suppose if I write here a salt, ice here, NaCl. Here, atom singly or atom ion, Na plus or Cl minus, we are observing here. Then one more, I'll give you example here. Suppose barium chloride salt I am written here, BaCl2. Here, Ba2 plus and Cl minus. If you look only composition, of the salts, here chlorine is observed as common in the both salts. This chlorine is observed commonly in the both salts. It may be with any subscript. Or you may observe that with common ion. With the common ion. So this we noticed here. So these are said to be here same family. How we are classifying them? Based on one ion, single common ion or common atom. It may be group of atoms also. For example, here sodium carbonate, Na2CO3. One more, MgCO3. Here, commonly available atoms, group of atoms here. Look at this, carbonate, right? So here, simply we can say these are also as a family. Maybe based on one atom or group of atoms, or one ion, common ion, group of ions. Based on them, we can classify them as a family. So here, family of salts. Salts can be classified into families based on common element or group of elements in their formula units. So here, maybe based on the ions also. So look at these here examples given in the activity number 14. So we defined what are salts and also defined what is family of salt. Then we are classifying salts into different families in the activity number 14. Here, different salts I am writing here to classify them into different family groups here. So how we are assigning the name for the family based on one atom or group of atoms. So here I am writing here ammonium chloride, magnesium chloride, sodium chloride, sodium bicarbonate, sodium carbonate, sodium sulfate, calcium carbonate, sodium carbonate, magnesium carbonate, aluminum oxide, ammonium sulfate, magnesium oxide, potassium sulfate, calcium oxide, KCl. So here simply, what is family of salt? It may be classified based on one common element or group of common elements as their name. Suppose here in the previous examples, I observed Cl commonly in a sodium chloride and barium chloride. So that salts are said to be here chlorine family. So commonly available element or group of atoms as name of the family. We are assigning as name of the family. So likewise here simply I can assign a name of the family for these salts. How many families you can identify among the salts given above? What are given here? From them, how many families you can assign here? Many, based on the common element available in them, right? So look at that families here. First one, suppose I am based on only one element, chlorine. Given is chlorine family. Find them and drop them. So here, what they are here? Ammonium chloride, magnesium chloride, aluminum chloride, sodium chloride, right? Or potassium chloride, like this. So as many as you can include into your list. You can add more number of salts also into this family, because commonly I am observing in the composition of the salts, chlorine atom. The next family here, simply that is taken sodium family. So here in the given salts, which has sodium commonly in them, they are taken as here sodium family. So what they are here? Sodium chloride, sodium bicarbonate, sodium nitrate, sodium sulfate, sodium carbonate, like that. The next family here, carbonate family. So which are having or commonly a group of atom carbonate CO3 is available. They are taken into the same family, CaCO3, Na2CO3, MgCO3, etc. Next family is here sulfate family. So SO4, right? Group of atoms. What they are here? Ammonium sulfate, potassium sulfate, ammonium sulfate, potassium sulfate. The next here, one more family I am able to derive here. What is that? Oxide family. Oxygen available, only oxygen with metal. So what they are here? Magnesium oxide, calcium oxide, aluminum oxide, trioxide. So this is family of salts. Then the next topic is here simply finding salts nature and classifying that salts into acidic salts or basic salts or maybe the neutral salts. So classifying them into acidic salts, basic salts or the neutral salts. So here finding the pH of salts. pH, that will give you the value, strength, finding the ions concentration with value, negative logarithm. So here pH scale we can use or a pH paper we can use, then finding the pH of the salts here. So you need to collect the samples from the laboratory. So they are called as here salts. Some samples we are collecting, namely they are here what we are collecting them from the laboratory, or they are here sodium chloride, aluminum chloride, copper sulfate, sodium acetate, ammonium chloride, sodium bicarbonate, sodium carbonate. These are the samples minimum, at least 4 to 5 salts, right? Then finding the pH of these salts. So here, as we learned in the activity 8, what we learned in the activity 8, ions produced only in the presence of water, aqueous solution. Ions produced by the chemical substances only in the presence of water. So here, all these salts are in dried form, dry salts. So here, simply, we have to make a solution of these salts, prepare aqueous solution of the salts. So here, simply each salt dissolved in the distilled water. So why distilled water? Because distilled water has any nature? No nature. Distilled water, neutral. If you add any salt into the acidic water, what happens? Its nature changes. Its nature changes. So that's why here I am suggesting you to dissolve that salts into the distilled water. Dissolve them in the different beakers using distilled water. Then finding the nature of the salts using litmus paper. Why litmus paper, sir? To know about the nature, right? Then verify that along with pH paper to find the pH value and to know the color of that litmus paper. So use the indicator 0 to 14 values, right? That values will indicate the strength with its color. Suppose if you obtain green, we can assign a nature and we can assign a value. So for that, we are using pH paper. So find the pH using the pH paper, universal indicator. Next term, we verified our result with two indicators. One is litmus paper and the other is universal indicator. We used both. Then decide, classify nature of the salt here as acidic, basic, or the neutral salts here. Acidic, basic, or the neutral salt here. Then one table is given in your textbook, activity number 15. Eyes here on the screen. So that has 3 columns to classify the salts from these into acidic salts, basic salts, or the neutral salts. Acidic salts, basic salts, or the neutral salts. So here, NaCl. First sample I am taking NaCl here. So NaCl taken and into a beaker, I'll take water, then adding that NaCl and dissolving. After dissolving, you will get a liquid solution of NaCl called brine solution. Okay, prepared. Aqueous solution of NaCl prepared. Then what to do? Use the indicator. What indicator? Blue litmus paper. Blue litmus paper, red litmus paper. Then find the nature. So what the effect on the litmus papers given by this NaCl solution? No effect. That means that blue litmus paper or red litmus paper remains in the same color. So here simply, when you use this yellow litmus paper dipping into the NaCl solution, what happens? Changes its color. In which color it changes? That you have to observe carefully. That changes into green color. So automatically, we can decide the nature using the color of the litmus paper, universal indicator. So yellow paper turns into green color, then the pH value is assigned 7, neutral. So we can classify the salts. Likewise, you are finding all the given salts, dissolving into the distilled water, preparing the aqueous solution, using the blue litmus paper, red litmus paper, noticing that observation, then finally using the universal indicator. Observe the color and observe the indicator to know the strength. Then if the pH value given 7, then the nature is neutral. If the pH value lower than 7, less than 7, it is acidic in nature. Above 7, basic in nature. So according to that, I am giving you example for the acidic salts, basic salts, and neutral salts here. Right? You need to remember them. Sometimes maybe in your examination, they may ask you to give example for the neutral salts. So neutral salt means maybe you will give one example for that. That is what sodium chloride. What about the other examples? They may ask you minimum 3 examples. How do you write? So for that, you have to remember ammonium chloride, acidic salt, magnesium chloride, acidic salt, aluminum chloride, acidic salt, ammonium sulfate, acidic salts. Then basic salts, calcium oxide, sodium bicarbonate, calcium carbonate, magnesium oxide. Neutral salts, important topic, neutral salts. So remember the neutral salts and examples. Sodium nitrate, potassium sulfate, sodium sulfate, ammonium acetate. And one more, you know, naturally, that is NaCl as neutral salt. So 5 examples you got here. 5 examples given for neutral salts. Note down them. Then here simply we know salts are produced by the neutralization reaction. Okay, it is how it is produced. Suppose here, if I ask you to produce MgCl2, how do you produce? That you have to learn. So by the reaction of acid and the base. So here simply to produce that salt, what the acid you are taking, what the base you are taking, that are called here parent acid and parent base to get the product MgCl2. So in the activity 5, we learned about one reaction to produce the salt, common salt, NaCl. So what are the parents, parent acid and the bases here? Parent acid is HCl and the parent base is NaOH. So find out parent acid and parent base to produce these type of salts. So it will help you to learn reaction. How do you produce these salts? Okay, so here simply by the strong acids and strong bases reaction, you will produce the salt with neutral nature. The salt with neutral nature. If you use strong acid and a weak base, strong acid and a weak base, you will get the salt nature with acidic. So acidic salt is produced by the reaction of a strong acid and the weak base. If you use both weak acid and weak base, then what happens? Simply here you are able to get the salt with weak acid and weak strong base. Weak acid and strong base. Here you are able to produce basic salt. Simple. If you want neutral salt, both strong or sometimes maybe both weak also, right? Then if you want acidic salt, here both are different. Both are acidic. Suppose if you want acidic salt, both are different, opposite combinations, right? So which is strong, that nature will be adopted by the salt. Okay, so like this we can produce the salts. That is discussed in the activity number 15. Then here we will discuss about some importance of a common salt in our daily life or maybe in the different sectors. So here chemical, that salt may be a salt produced from the common salt. They are called as here chemicals from the common salt. So what you are able to produce from the common salt, right? So here, what is common salt? It is an ionic compound. It is an ionic compound that is produced by the neutralization reaction between the sodium hydroxide base and HCl acid. So strong acid and strong base reaction is producing the common salt. So here simply about common salt, what we can write? It is an ionic compound and it is produced by the neutralization reaction of HCl and NaOH. And here that salt NaCl is predominant compound. Why? Here there are many salts produced by the common salt. We have many salts like as mentioned in the activity number 15. What? Magnesium oxide, sodium oxide, sodium hydroxide, sodium sulfate. Many salts are there, but special salt is common salt. Why it is predominant, dominating all the salts? Why? It is used as a base source for production of many salts. So that's why it is special. Okay. So here many salts are produced by the neutralization reaction only. But here simply to produce the different salts, we are using this NaCl as a basic substance in the reactions, right? So here about NaCl, it is an electrically neutral itself. But if this NaCl dissolved in the water, it produces different ions called Na plus and Cl minus, is anion and cation. Na plus and Cl minus. So Na plus is called cation and Cl minus is called anion, electrically neutral. So here this sodium chloride also known as table salt or a common salt. Sodium chloride chemical name, and that sodium chloride called in our daily life or by a common people as table salt or a common salt. Here this salt is produced from the seawater, and also this salt may be available as deposits. Why? That means a deposit means as mining of coal. How we are getting the coal from the mining. Like that, this salt also obtained from the mines that are located in different states in the northern region. How they are formed? Maybe in the ancient, some seas are dried by the bygone of ages. So they are formed as here simply deposits, that salts dried, seawater dried, and the salts are remained as deposits. So here that NaCl is in a brown color called rock salt. Brown color and called as rock salt. Here, why it is available in brown color? Because of impurities, other substances combined with that, pollutes, right? Impure. So that impurity is giving the color as brown here. By the purification, we can use that as common salt or a table salt. So here they are formed as beds, right? Beds of rock salt were formed when seas of bygone ages dried up. Rock salt mined like a coal. It is obtained by the mining as like a coal here. Simply, that salt is used as preservative in our day-to-day life, and it is only enhancing the taste of the food. So this information you can write about common salt. Some uses of common salts are just what information do you know about chemical salt? Explain. So these simple terms we can explain about the common salt, right? Then here simply the next topic is about the chemicals obtained from the common salt. Previously I said or I mentioned about the importance of common salt in our daily life, right? Common salt used as an important material for various salts obtained in your daily life. Materials, production of different materials or chemical substances in our regular life, we are using them, right? So what they are here? Simply sodium hydroxide, baking soda, washing soda, bleaching powder, and many more are produced by the salt products. Common salt we are using as a major source for the production of different salts. That's different salts may be used in different reactions to produce other compounds, but the major source is indirectly NaCl. So that's why here we are giving importance to this common salt. Suppose here production of this sodium hydroxide from the common salt, production of sodium hydroxide from the common salt. So here sodium hydroxide produced by the electrolysis process of a common salt. That means common salt dissolved in the water, then the liquid supplied by the electricity, passing electricity through that aqueous solution of a common salt. So likewise here we are producing this sodium hydroxide from NaCl aqueous solution. So here that process named as chloroalkali process. The process named as chloroalkali process. So here sodium hydroxide we are producing by the chloroalkali process. What is chloroalkali process here? Very simple to say. Chloro. it stands for the chlorine gas. Alkali stands for the base dissolved in the water. The base which dissolved in the water called as alkaline. So alkali stands for the base dissolved in the water. So here, by the electrolysis process of sodium chloride aqueous solution of salt, brine solution called as brine solution, you are producing a base dissolved in the water remains in that, and a gas produced chlorine. So based on them, we are assigning the name for the process is called as chloralkali process. Here simply, when electricity passed through an aqueous solution of sodium chloride, what happens? Decomposes. That sodium chloride solution, aqueous solution of brine, right? Brine solution, right? Here decomposes into sodium hydroxide and chlorine gases here, along with hydrogen gas. So here, this process is called here chloroalkali process. This process called here chloroalkali process. That process carried out in the laboratory as you see in this diagram. So here they are maintaining different conditions and they are supplying that in different percentages, right? So here at the anode, what we are collecting? Chlorine gas. At the cathode, they are collecting hydrogen gas. The liquid remains in the container is called sodium hydroxide solution called alkali. So chloroalkali process, it is simple electrolysis process of NaCl and decomposes that into sodium hydroxide dissolved form liquid solution called alkali, and the chlorine gas liberated in this process. So that's why that name assigned based on that is chloroalkali process. So this is chloroalkali process for the production of NaOH. For the production of NaOH. So here this process you are also able to write as equation here. You are able to write in the form of equation. What is that here? NaCl in the presence of water gives you aqueous solution called brine solution. Then here, when you supply that electricity through the liquid solution of NaCl, what happens? Decomposing into sodium hydroxide aqueous solution, and the gases liberated here called chlorine and hydrogen at anode and cathode differently. So this is chemical equation for the process of chloroalkali, production of NaOH. Simply, we have learned about these two topics. Then the next topic is other important salts are produced in this reaction that we are learning. Simply preparation of a bleaching powder here. Bleaching powder. So how you are producing this bleaching powder? How you are producing this bleaching powder? So before that, in the previous what we learned, about production of this sodium hydroxide, chlorine and hydrogen gases. Production of these compounds, what they are here, namely NaOH, chlorine and hydrogen gases. So here chlorine and hydrogen gases are said to be here byproducts. Chlorine and hydrogen gases are said to be here byproducts. These products we can use in a different ways. Suppose about sodium hydroxide. That sodium hydroxide we are using as degreasing of metals. Degreasing of metals. Suppose here that metals, to avoid rusting formation, lubrication process. That means applying the oils and greases on the surface. To remove that, we are using NaOH as degreasing metal substance. Right? Then it is used in the soaps production, soaps industry. One of the source material for the sodium mineral. So sodium hydroxide used in the soaps and detergents production. Next, this NaOH also used in the paper production, also used in the production of artificial fibers. Artificial fibers. Chlorine gas. Chlorine gas used in production of pesticides, fertilizers, disinfecting treatment of water treatment plants. In them, we can use this chlorine gas for the chlorination process. In the swimming pools, also we can use this chlorination process. In the production of PVC pipes, we can use this chlorine gas. Hydrogen gas, we can use these hydrogen ice fuel. Ice fuel, we can use these in the production of margarine, in the production of fertilizers, Also, we can carry out the reaction between these gases, hydrogen and chlorine, to produce HCl, hydrochloric acid production by this chlorine and hydrogen gases. Ammonium chloride also produced by the reaction of these hydrogen and chlorine, HCl production, that reaction with the ammonia, chlorine, right, or hydrogen with nitrogen. Ammonium chloride or ammonia we can produce by these gases. Also, we can produce medicines, cosmetics, or this also used in the cleaning of steel, chlorine and hydrogens. Then here, using the sodium hydroxide and chlorine, we can produce bleach, CaOCl2, bleaching powder. Also used that in the bleaching of that reaction carried out to produce bleaching powder, used in bleaching of fabrics and using in the household bleaching. That means floor cleaning, water purification process. In them, we are using these salts, right? So 3 products we obtained: chlorino, hydrogen, and sodium hydroxide. Remember the uses of these three substances individually. These 3 substances individually. Then let us go for the next salt production, that important salt produced from the sodium hydroxide or byproducts of this chlorine and hydrogen, right? Byproducts of a chloroalkali process, hydrogen and chlorine. So that can be used in this preparation of salt. So preparation of bleaching powder. This bleaching powder is produced by the action of chlorine gas, on slacker lime. Action of chlorine gas on slacker lime. What is slacker lime here? Lime water. So here lime water formula CaOH2, calcium hydroxide, will be react with chlorine gas and produces CaOCl2 and water. So here simply this CaOCl2 chemically called as calcioxychloride, right? So here chlorine gas react with CaOH2 and producing CaOCl2, commonly called as bleaching powder. So chemical name of bleaching powder is calcium oxychloride or calcium chlorohypochlorite. This is chemical name of the bleaching powder. Simply, commonly in our daily life, we are calling as bleaching powder or calcium oxychloride. That is the chemical name. Then next here, we will see about the uses of this salt, bleaching powder. So uses of a bleaching powder. It is used in our daily life. In the water as a source of chlorine gas, right? But that used in different sectors. So this bleaching is used as oxidizing agent in a chemical industry, in chemical reactions, used as a oxidizing agent. This bleaching is used to treat the wood pulp, maybe to remove the color in paper industry. In paper industry. So bleaching wood pulp. Why? To change its color. Used as decolorizing agent. It is used as decolorizing agent. So in a paper industry or in the textile industry, cotton and other linen, bleaching of that fibers or fabrics. So what happens? They can remove the color. They lose their color. It is used as a disinfecting of drinking water, sterilizing, right? So sterilization and the disinfection of drinking water, used as source of chlorine here. In the manufacturing industries, right? What they are here? Weedicides or insecticides, chemicals that which help in a fertilization process, right? Also used as reagent for preparation of a chloroform, CHCl3, chloroform. So these are the applications of a bleaching powder. In the next class, I'll discuss with you about remaining salts, and one more activity is there. It is about water of crystallization. So that topics we will learn. So thank you for joining in the live on YouTube. So also inform to your friends about these classes if you like. Subscribe and click on the notification to know about your live sessions.